In lesson 2, we're going to talk about sample spaces and tree diagrams, which this has to do with outcomes and probability if you're given different types of probability to combine. So sample space is the set of all possible outcomes. The outcomes cannot overlap, meaning they cannot be picked more than one time. And it can be represented as a list or what we like to call a tree diagram. So we're going to kind of experiment, and I'm going to show you both. So let's look at a list option first. In question 1, if you can choose a card from a normal deck of cards, what are the number of possible outcomes from the cards you chose? So if you don't know anything about cards, this could be truly difficult, but we would typically get out a deck of cards. And if you do know stuff about cards, you know that there are 52 different types of cards in a deck. So if you are just going to choose one single card, you are going to have 52 different options or outcomes for that one card. If you picked it one time, you would have 52 choices. Question number 2. If you roll a 6-sided dice 2 times, what are the number of possible outcomes? So you have 2 different rolls. So you know that a die has 6 different sides with the numbers 1 through 6. So if you were to roll it the first time, you want to list that you will have 6 different outcomes as your choices. But it's telling you to roll it twice. So we have a second roll. That same dice would be used in it. So that means there are 6 options on that die. And when you have multiple options in an experiment with possible outcomes, you multiply those and it tells you your total outcomes will be 36. So once you can wrap your head around these, they actually become very, very simple because they're just multiplication problems. Question number 3. A couple has 3 children. What is the sample space for the gender of those children? So I'm going to kind of list out to the side. We have the first child, like myself. We have a second child. And we have a third child. And for those, each time they can be a male or a female. So in the first route, you can have a male or female, which is 2 outcomes. And the second child, male or female, 2 outcomes. And then for the third child, male or female, which is 2 outcomes. And like I said, every outcome you multiply by the next. So this gives us a total of 8 different outcomes for the gender of 3 different children. So we're going to look at this to list all possibilities in a more systematic way, and we call this a tree diagram. So we're going to use question 3, and we're going to use a tree diagram to list this out. And I'm going to list, so I'm going to say the first child can either be a male or a female. And then I'm going to move down in my tree diagram, and I'm going to kind of add what we'd say leaves to the tree. So the second child. So the leaves come because if you have a male the first time, the second time you still have a chance of having a male or a female. But if you have a female the first child, you still also have a chance of having a male or a female in the second child. So then this has a third row or a third child. So you could have a male, and then still have the option of having a male or a female. You could have a male, a female, still. Third kid could be a male or a female, even after a male, then a female. You could have a female, then a male, still have those same 2 choices. Or a female and then a female, and you still have those 2 choices. So when you look at all of this in the tree diagram, you have to systematically list your first child as a male or female. And then you go down, you still have those options for your second child. And then you still have that option for a third child, and it branches off as you go down the tree diagram. Let's look at question number 4. You flip a coin and then you spin a spinner. So we have 2 different options here to make our tree diagram, and then we're going to list it out in what we call a sample space. So I'm going to list our options first. We have a coin. The coin can either have heads or tails. And then we have a spinner. And we're just going to name this spinner, since it has 4 sections, as 1, 2, 3, and 4. And we're going to make a tree diagram. So since we have to do a flip of a coin and a spin of a spinner, I'm going to start by listing heads and tails for the flip of our coin. And then under each of them, I have to list all my options for my spinner. So I have a 1, a 2, a 3, and a 4 under heads. And then if I were to flip tails, I still have those same options. So the sample space is a list method going from this tree diagram, and I'm going to try my best to highlight as I talk. So my first outcome could be heads or a spin of 1. So I say H1. My second option could be flipping a heads but getting 2 on my spin, so H2. My third option, I could get heads and spin a 3, H3. My fourth option, I could get heads and spin 4. But I could not get a flip of heads at all, so I could get tails and spin a 1. I could get tails and spin 2. I could get tails and spin a 3. Or I could get tails and spin a 4. And what that leads me to get is this sample space right here that tells me my total outcomes are 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. Let's move on to question number 5. In question number 5, I have a lunch menu choice of the following, and you are able to choose one from each category. So from the meat, I have a hamburger, a hot dog, or chicken. From the starches, I have French fries and baked potatoes. And from the drinks, I have Coke and tea. So the first thing we're going to do is we're going to make a tree diagram. So from that tree diagram, I am going to use abbreviations. So I'm going to start with the hamburger, hot dog, and chicken. So I'm going to label them HB, HD for hot dog, and C for chicken. Then I'm going to move down and I'm going to list my French fries and my baked potato as my next set of options from each of the above. So I have French fries and baked potato as an option here. I have French fries and baked potato as an option there. And if I choose chicken, I still have French fries and baked potato as my option. And then I have to move on to my drink selection, which is Coke or tea. So I have a Coke or a tea for that choice. Coke or tea here. Coke or tea here. And I list that for each of the branches of the tree diagram. So now what gets kind of tricky is going through all of those options. And again, I'm going to try and highlight as I go. So my first option could be that I choose a hamburger, French fries, and a Coke. So when I list that, I'm going to say hamburger, French fries, Coke. My next option could be that I want to choose a hamburger and French fries, but I want to have tea instead. So I have hamburger, French fries, and tea. Third option being I want a hamburger, but I want a baked potato and a Coke. So hamburger, baked potato, and a Coke. Change my mind. I really want hamburger, baked potato, and tea. So hamburger, baked potato, and tea. Now I move over. I don't want a hamburger at all. I want a hot dog. So I'm going to go down all of the branches for hot dog, so forth and so on, and list them. So I have hot dog, French fries, and Coke. Hot dog, French fries, and tea. Hot dog, baked potato, and Coke. And hot dog, baked potato, and tea. So very systematic. Now I move over to the chicken selection. So I want chicken, French fries, and a Coke. Notice I keep them very similar when I'm writing out the sample space. I want chicken French fries in the T. Chicken baked potato in the Coke. Or chicken baked potato and the T. Now I've probably made you hungry. All right, so I can see from my sample space, I can figure out all my total outcomes. And I have 3, 6, 9, 12 total outcomes for this sample space and tree diagram. Okay, so you are going to go through and you are going to do the tree diagram and sample space worksheet in Canvas, and there is an entry. So if you do those on paper, make sure you go ahead and put those in the Canvas quiz.